Hello, everyone, and welcome to our Geek Out series. I am Jennifer Johnson, Account Executive with Prolifics, and I'll be your host. A few housekeeping things before we get started. I'd like to remind everyone to please mute your microphones. Also, please know that we are taking questions. The geekier, the better, and you can enter those on the right-hand side of your screen in the chat. Speaking of geeks, let me give you a little bit of background about our speaker. Don't worry, Dr. G, it's a compliment, I promise. Dr. Gonzales, Dr. G as we like to call him, holds a PhD from the University of Texas with a concentration in information and decision science. He's a successful author and industry-leading speaker and is currently the Chief Data Scientist for Prolifics. Yay! Today we're going to talk about leveraging machine learning techniques to conduct a robust, thorough audit on business rules, semantics, and physical data layers of your analytic and reporting systems. So why is that important? What we're really talking about here is looking holistically at multiple servers and examining how the code interacts with them, the layers of programming that are making requests, and the data sets back and forth between those multiple servers. So Dr. G, what problems might surface to cause a company to consider this?
Well, first of all, thank you for the introduction, Jen. Appreciate it. One of the things that I oftentimes experience from clients with multiple platforms is kind of like a symptom of performance. So generally, you know, you ask clients,
join the meeting,
if they're experiencing anything like, are your reporting servers or your analytic servers, are they increasing or growing faster than you had earlier anticipated? And are you adding more servers just simply because of performance issues? Or are some of your back-end servers, are they hitting the maximum limit of their size and you have to upgrade, go to the next level that's going to cost you, a few $1 million to make that?
Join the meeting.
So generally speaking, that's what we're looking for, is issues about performance, and they could be performance issues on the front end or the back end. Generally, systems bogging down, right? Generally, their performance is becoming more and more poor. So generally, you have these customer-facing type of applications. They can be BI reports, they can be dashboards, they can be analytic type of front ends, for predictive analytics, geospatial, exploratory analytics, any of that. One more time, if you would please, just click. Generally speaking, all of those front-end applications are supported by a mid-tier type of server. So let's click just twice, and let's get them both up there. One is more like a BI reporting type of server farm that's used, maybe it's a BobJ or a Cognos or whatever. The other one, a common one that we run into anyway, is an analytic farm. It could be SAS, it could be an SPSS set of servers, it could be any number of different analytic type of applications that require their own server to support their data processing. But all of that actually is fed from a set of servers. If you click one more time, a set of servers even further back, and they're really the data servers, right? So when I talk about a performance issue, it's really a balance between the mid-tier servers and those back-end servers. It's really the communication between those servers, Jen. So in this case, I have identified, a couple of layers of SQL, just simply because that's a common language that these servers are going to communicate with. We're not talking about network protocols or any of that stuff. We're talking about just databases talking to each other and applications requesting information from one server, and that server throwing that information back. And so this is where we see those performance problems encountered.
So you mentioned in previous conversation that large global organizations with strong IT and data science skills are surprised by your approach to analyzing the data interaction between large platforms. What is it about this approach that surprises them, these experienced teams?
Well, so first of all, they all have seasoned, skilled players. Take, for instance, $69 billion entertainment industry, right? I mean, this firm has some serious technical individuals that understand the back end, understand the mid-tier, or a $16 billion manufacturer distributor. Again, serious skill sets, understand the back end, understand the mid-tier. But generally what we see happening is that even with all of that skill, they're missing the analysis of the code of the whole, right? Of both servers combined. So you're going to have great skills as a DBA, for instance, in a back-end Teradata system, or an Netezza, or a big Oracle EDW. Or you're going to have great technical skills for BobJ servers, or SAS servers, or Cognos servers, right? But those skill sets are actually what are part of the problem, because they introduce bias, right? So if I'm going to invest heavily in a BobJ farm, say for instance that $69 billion entertainment company, they had a Teradata backend, they had a BobJ server farm as the mid-tier, and we were charged with making sure that the development team on this 5-year project were actually doing the right things, right? They were developing the code correctly, adhering to standards, that kind of stuff. Well, so the development team, they go out and they hire a bunch of BobJ experts. They're experts on that particular platform. They can crank out reports all day long, but they know nothing about the backend problem. They know nothing about Teradata, even if they had access to it, which they may not be other than to extract data. So in this particular client situation, the simple fact that they hired a bunch of BobJ developers really adds to the bias, to the problem, because the BobJ developers are basically going to bring whatever data over onto the reporting server side so that they can manage it in an environment that they're comfortable with, which basically means it's really not a technical issue of performance. It really ends up being inefficient code, where they're writing a bunch of code just to extract a whole slew of data from the Teradata box and sticking it on their box just simply because that's where they're comfortable. But as far as an investment is concerned, in this particular case, the client wasn't getting the value out of that big multi-million-dollar back-end data server, and they most certainly weren't getting the type of ROI that they expected on the reporting side of the street, simply because it kept on growing bigger and bigger than they had originally intended. In the case of the $16 billion manufacturing distributor, they had a Cognos server farm, they had a Teradata server farm, or EDW, and they were suffering problems on both sides of the street. They were suffering a big, extensive growth on the server farm for Cognos, and they were pushing the upper boundaries of this particular size of Teradata platform. The next size was going to be a lot larger. So we were brought in actually to see where the optimization is, so at least we could postpone, if nothing else, you know, the inevitable upgrades. But if we could at least postpone that, push it back, and make their current resources more efficient. So what we see here is that integration, even though they have the right skill set, the communication between these two servers is really the issue. And neither the DBAs on the Teradata side of the street in this example, or the business objects or the Cognos side of the street, they're really not talking to each other. They're writing great code given their own platforms, but they're inefficient in the way that they're communicating across platforms. And so you have to consider how many programs we're actually looking at, right? So we're using machine learning to actually consume the amount of lines of code. If you're just two platforms, a business objects and a Teradata, you know, you could be in excess of, you could start pushing 2,000 programs alone. And if you think about that, 2,000 programs, and each program, say, for instance, you know, has 50 lines of code, you're talking about a serious amount of lines of code that nobody's going to ever be able to eyeball. And as a matter of fact, if we put the slide up one more time and hit next, if you would, this situation is made worse by, if you just click one more time, yeah. It's exacerbated, it's made, it just further complicated by the difference between a semantic view and a physical layer. Now, I have semantic and physical layers on the mid tiers because they could certainly and will likely execute this kind of a scenario. On the backend server, I guarantee you a wonderful platform like a Teradata box is going to exercise a physical layer and a semantic layer. And that semantic layer is going to have, it's essentially multiple layers of views. They're either logical views or they're materialized views, but they're essentially SQL programs that are going to extract data from the physical side, do in-flight transformation of that, and push it to the requesting set of servers. So now we're not only talking about SQL to SQL, but within each one of these platforms, you could have multiple layers of SQL, which only increases the amount of programs that are actually, you know, communicating.
So we're analyzing how the servers interact with each other. What does the final analysis look like? And is this something executives can understand? Is it actionable?
Absolutely. So we're using machine learning to actually extract what's going on between these multiple servers. So if you click on the next slide, this will give you an example of what we actually can present to executives. And it's really using text mining techniques. It's really clear the imbalance. It's really clear how these platforms are actually being exercised, right? And so with text mining, we're able to isolate very specific words. So in this case for SQL, there's some words, there's some terminology within SQL that actually are resource pigs for all intents and purposes. They just really suck up a lot of resources. And a couple of examples, for instance, up here I have sum, concatenation, trim, you know, a case statement, substring. These are all terms that can cause a lot of overhead to be consumed. So those are the SQL terms, and this is actually the results of a real use case. And then we have the business objects, the Bob J layer. So the number of times that particular term was used, and the number of objects. In this particular case, there were over 300 business object programs already in development, right? So, and they were just like in year 3 of a 5-year development program. On the Teradata side of this same scenario, we have logical views, the amount of times that term was used, and in the number of views that term was used, and then materialized views. So we're distinguishing between logical views and materialized views. But the granularity of where we can actually concentrate on where this term is used, and not just on which platform, but we can actually point how many times this term is used and in exactly how many different programs this term was used, and be specific about the program so that we actually have the beginnings of a roadmap, right? We know where we need to start in terms of resolving issues. But let's take a look at sum as an example. So if we click next, just one more click, there you go. So you can see here where sum, that term, is used 108 times in 80 objects. And it is used some in the logical view of Teradata, and none of the views that are materialized views are actually leveraging that term. So most of the heavy lifting is really happening on the business object side of the street. If you look at concatenation, which is a real resource intensive operation, you know, you're talking about building a single attribute out of 2 or more attributes, slamming them together. And basically it means that the data is not stored in the manner that business wants to analyze by, right? So business wants the term that's kind of slammed together by multiple attributes. And in this just horrendously expensive operation, it's occurring 118 times in 35 different programs on the business object side of the street. On the Teradata side of the street, it's doing no heavy lifting, none. So in this particular case, Teradata is little more than a passive repository. Now this is a monster machine, and this is a machine that could actually be doing this kind of work probably a heck of a lot better than performance-wise than I could ever expect out of a reporting server farm. And yet in this particular case, it's doing no heavy lifting. If we hit click again, trim, it's more than just, lopping off leading spaces or zeros or whatever, or trailing zeros and spaces. It's still a resource intensive operation. And again, in order to get the information in the format that business wants to see it, Business Objects is doing all the heavy lifting, 104 times in 18 different programs. And Teradata, nothing. So really, this epitomizes the developer bias, right? I don't really control the Teradata box. I don't know much about Teradata, so I'm going to do a select splat. I'm just going to drag everything on over, and I'm going to plop it in my environment, the one I know how to work with, and then I'll do whatever I need to get done, right? So the client in this case is not leveraging the Teradata at all. And more importantly, they're spending more money on the reporting server side than they actually should be. And it's not the technology per se, it's just inefficient code. And it's the code, it's actually when you look at the composite whole. So this is the kind of information that clients are able to start making decisions about. It's obvious where the issues are, right? It's obvious where the problems are. And that's the value of this particular technique.
And so it's not even that what's being done is so wrong, it's where it's being done. Because they're not taking advantage of the right servers.
Exactly.
Yeah.
And so, and even if you try to solve one problem, I'm sorry, I just wanted to interject something, Jen. Even if you try to solve a problem, let's just say, for instance, you're executing a query and it's always bogging down, so you have a bunch of people complaining about it. You get some DBAs, a couple of DBA geeks sitting out on the Teradata platform. They'll slap an explain on it. They'll watch the query. They'll fine tune it for indexing and partitioning, whatever they want to. But that's like throwing a dart, right? That's a very specific solution for one issue, right? But you're talking about, 100,000 lines of code. That issue is everywhere. There's a lot more times when that issue appears. It just doesn't happen. It doesn't come up to a complaint level where everybody's furious about the performance. So it's really just those rifle approaches to trying to solve it just won't get it done unless you're looking at the cohesive whole. I mean, both services at the same time.
Yeah, that makes sense. So mostly what we've talked about so far is SQL, but what about other languages like Python, SAS? Does it work for those as well?
Absolutely. SAS procs is just a simple scripting language. Python, again, wonderful. I'm not trying to downplay the languages. They're good languages. They're relevant in our space, but the language is incredibly limited, just like SQL is an incredibly limited language. So what we do is we'll build a word dictionary based on the language that we need to analyze, right? So it could be PySpark, Python, SAS procs, SQL, right? You just build a word dictionary so that you can enable your text mining process.
Okay, so now we've identified all the location of the resource-heavy calls, be it SQL, Python, one of the other languages. So now what? So how do we fix it?
Well, so like that screen that I was showing you, where you could clearly show that a particular term, concatenation, we clearly know where it's occurring and where it should be occurring. If we're going to have to do it, where is the better place to do it? And we also have a clear relationship of where it's actually occurring. So it's not just the term, it's the exact programs that are invoking that term. That gives us the start of our roadmap. That tells us, okay, so now we have a starting point. We know where they are and we know what they are. So I've seen two different ways to resolve the issue. One is to actually introduce standards during the existing development. In other words, the sprints that are going on right now, we now introduce standards so the dev teams know that if they're going to execute this kind of term, we need to make sure that we're considering both platforms, and we get the right resources to comment on it, right? So you shouldn't have a dev team that's just business objects if they're sourcing all their data out of Teradata. You need to have a Teradata geek a part of that dev team, right? So that's one resolution. The other thing that I've seen is where a whole different initiative is budgeted and invoked, where it's just basically a standardization initiative. And we take the most offending terms, right? The most resource intensive terms, and we set up a standardization process. You know, you can't just do it on the back end without affecting the front end. So we actually try to do both in a nice cadence and work our way down to the less and less offending terms. And as we do, of course, as we get the bigger ones done, you'll start seeing a definite improvement on performance for both, as a result of both platforms being optimized.
Okay, so that makes sense. So really we have a two-prong approach. One is to fix the problem going forward, and the other is to step-by-step go back and change what's already been in place. Right. So now I have one more question before we open it up to the audience, and this is a big one. So I'm curious as to where you've seen the biggest client savings so far and what that project looked like, how that went down.
So I want to preface this by saying it's probably a horrible thing to say, but it's hard to quantify, you know, so many different terms being used and exactly how much resources you're actually saving, right? It's not a trivial thing to try to quantify. But I do have a situation where the client gave me a dollar figure. I mean, this is their dollar figure. They said, I saved them $1 million. And, you know, I'm going to take them at their word. But it had to do with a SaaS mid-tier server and a Teradata backend. And the SaaS folks, wonderful folks that they are, they wanted to build a tier one, basically a critical system where it could not fail. And it was going to cost a bunch of hardware as well as upgrades on licenses. And that's where basically the client came up with that $1 million. So they were arguing for a big production type of platform. And when I did the text mining analysis between the communications between the SaaS mid-tier and the backend Teradata, I found that SaaS wasn't actually doing anything more than asking for data from the backend server. And for that type of analysis that they were doing in that SaaS environment, it's actually could be done in SQL on the Teradata platform, right? A lot of people don't know your SQL could actually do data mining functions, just like OLAP functions. And so basically SaaS wasn't executing any of that. They had already bought the extension. The capability of data mining in SQL is already in Teradata. It's already in the environment where the data actually resides, right? So I told them that none of this is being executed. And frankly, if you did do that, you wouldn't have to build this big, giant box of production environment. And then they asked me, well, just, basically put your money where your mouth is, prove it. And so I did. You write the SQL in SaaS. SaaS proc sends over the request. Teradata does exactly that data mining function. And instead of dragging all the data over, it just simply sends you the resultant set, right? So the server didn't have to be expanded to this giant thing. So the only ones that were upset with me were, of course, the SaaS salespeople. But so it was $1 million, and that was a number given to me by the client.
Right. What are you going to do?
What are you going to do?
Okay, so ladies, we have come to that so special time in the discussion where we're going to answer questions directly. So if you haven't already, if you have questions, please put them into the chat. And in the meantime, I have a couple that have come through already, Dr. G, so I'm going to go ahead and send those over to you. So the first question is, when you execute this type of analysis, how long does it take?
And I don't, I don't mean to be coy, right? So it depends. But if you think about, let's just scale it by like 2 servers, a business objects, a Cognos or a SaaS server, and one back-end data server. A lot of it is set up. The text mining itself will absolutely blow through, thousands of lines of code without a problem. but the setup takes time. So assuming that we have access to the right things, and you know, it could be as little as 2 to 3 weeks to get the entire analysis done. It is mind-boggling how much and how effective we can be in that limited amount of time. But using machine learning just, you know, it gives us a lot of, just enables a lot of robust analysis done in a short period of time. So it doesn't take that long at all.
That's amazing. When you really think about the comparison of how long it would take somebody to do it by hand, that's really impressive.
They don't do it. That's exactly what the problem is, that they never really they never analyze the cross-pollination between these SQL requests.
Yeah, I don't even like to go back and reread my own email, let alone thousands of lines of code. So one more question. The next question is, so can a company learn to do this themselves?
They can. You know, what we try to do is mentor our clients to learn it. And I got to tell you, and it's not for, you know, being a philanthropist or anything like that, but I do believe that a client should periodically do this. It's kind of like a house cleaning thing. So if we empower them to do it the next time, we mentor them through the first time, we empower them to do it the next time, and give them the right tools, absolutely, they should be able to do it periodically themselves. Absolutely.
Okay. So I have it on special authority for everyone who's here today to offer a complimentary 1-hour whiteboarding session with Dr. G. We can go through your specific environment and talk through how this would work for you. If you're interested, please reach out to solutions@prolific.com. You can get to that from the Geek Out webpage. And if you really want to make us laugh, please feel free to add the subject line, "Help me geek out too." That would make my day. Our next session is Geek Out on digital workers, and that's going to be October 6th. And we're going to dive into the future of digital workers with RPA, AI, and ML. And we hope to see everyone there. And thank you for coming today, guys.